guys want to say hi? Hi. Okay. All right. So now we are going to go through this worksheet, practicing using postulates and definitions and proofs. Okay. So segment addition postulate. If we're gonna make a proof, I should probably not talk quite as loud. Okay. Okay. So segment addition postulate. Always with segment addition postulate, it is going to be a statement and a proof where you're looking at a diagram and just naming this little part of a segment plus this little part of a segment equals the whole segment. You're never going to have measures in there. You're not going to have numbers. You're not going to have like length is 5 and you're going to stick in a 5. No numbers. The only numbers would be like if you're using angle addition postulate and it's like angle 1, right? Angle 1, but that's not the measure of the angle, right? So you're not going to look for any numbers in segment addition postulate or angle addition postulate. Just stating that this little part plus that little part equals the whole thing. So this is a proof using the segment addition postulate. We are given that AB equals CD. Okay, we are given that those two are actually equal to each other. We are trying to prove that AC is equal to BD. That's what we're trying to prove. Does it make sense to you that if AB equals CD, then AC would equal BD? Why is that true? What's the same? From where to where is the same? What do they share here? Maddie? They share BC, right? So BC is the same for both, so it makes sense. Okay, so that's the logic. Let's start AB equals CD. What's our reason? Given. Now we're going to say AB plus BC equals CD plus BC. What's happening from this step to this step? You add BC to both sides. Sometimes that's a little tricky to notice. They're adding BC to both sides. So yes, this is addition, property of equality. Now we're saying AB plus BC equals AC by the segment addition postulate. AB plus BC equals AC by segment addition postulate. We have to fill this in. Bless you. BC plus blank equals BD. What goes in that blank? BC plus CD equals BD. Now, what's happening here? AC equals BD. It's a tough one. AC equals BD. That equation, AB plus BC equals CD plus BC, right? Now we have AB plus BC here. It's the same, right? That green box. And BC plus, oops. BC plus CD, it's the same. So look what happens. They are taking this green box and replacing it with what's equal to that green box here. Exactly. And they're taking out this red box and replacing it with what's equal to that red box. Right? BD is equal to that red box. So we're taking it out and putting in the BD here. So this is going to be substitution. That was a little bit tricky to see. Remember though, if you're tempted to say subtraction or whatever it was, you got to remember you are looking for the same exact thing on both sides being subtracted. And if you can't look from one step to the step you're working on and say, oh yeah, look at that, they subtracted whatever from both sides, then you can't use subtraction. You really have to justify what you're using. Okay, so since AC is equal to BD, we can say AC is congruent to BD by what reason? Definition of congruent, right? Whether we're going from congruence to equals or equals to congruence, your reason is going to be definition of congruent. Okay, this is actually the proof of something called the overlapping segments theorem. We don't use it that much, though. Pretty much. Okay, angle addition postulate. Okay, so same idea here, but now we're using angles. So the given, we're going to list all the givens here. Angle DEF is congruent to angle IHK, and angle 1 is congruent to angle 3. That's given. What's our next statement going to say? If we know that our reason is definition of congruence, what's our next statement going to say? Yep, we're going to turn everything into measures. Definition of congruence changes us from congruence to equals or vice versa. So in this case, we just turn everything we knew as congruent into something as equal. Now, angle addition postulate is our next reason. So we need to say, using this angle first, we need to state the angle addition postulate using that angle. What are we going to say? Measure of angle what? DE, let's do the little one first. DEG, I'm going to call it angle 1 though, okay? Measure of angle 1, which is DEG, plus the measure of angle 2 equals the measure of angle DEF. Right? This part of the angle plus that part of the angle equals the whole angle. That's how we state the angle addition postulate. I left a big blank here because we are going to do the same thing for this one in the same step. Anytime you can make a bunch of statements using the same reason, you can put them all in the same step. So we're going to do the same thing here. Measure of angle 3 plus the measure of angle 4 equals the measure of angle, what? IHK. That's all by angle addition postulate. Now look at number 4, step 4. 1 plus 2 equals 3 plus 4. What's the reason? We have 1 plus 2 equals DEF here. We have 3 plus 4 equals IHK there. So why can we say 1 plus 2 equals 3 plus 4? Substitution, right. Again, it's like you're just rewriting the equation. Let's say we're rewriting this equation here. The 1 stays a 1, the 2 stays a 2. DEF turned into 3 plus 4. Actually, that's not really right. Sorry. Sometimes I mess up on my videos. It's okay. This one, we're rewriting this one. This equation right here, DEF equals IHK. We're taking out the DEF and we're replacing it with what it's equal to, 1 plus 2. We're taking out the IHK and we're replacing it with what it's equal to, 3 plus 4. Okay, so it's really substituting back into step 2. All right, now from step 4 to step 5. 1 stays 1, 2 stays 2, 3 becomes 1, and 4 stays 4. What's our reason? Patrick? We have established that 1 and 3 are equal. right here in our given and right here in our definition of congruence. But what is the reason? What did we do from here to here? Substitution. We just took out the measure of angle 3 and replaced it with the measure of angle 1. And we were able to do that because we established 1 and 3 equal before that. Okay, now going from step 5 to step 6. What changes from step 5 to step 6? Melissa, what did you subtract from both sides? Subtract the measure of angle 1 from both sides, and you get step 6. Measure of angle 2 equals measure of angle 4. Now, the last step, we wanted to match our proof. By definition of congruence, we're going to say, oops, angle 2 is congruent to angle 4. Okay. All right, let's look at the back. Linear pairs. Definition of linear pair, that's going to be used, like we said, just when you're looking at a picture and you're identifying it, saying, well, look at that, there's a linear pair. Linear pair postulate, stating they're supplementary, actually using the word and spelling it out, supplementary. So I'm going to actually pause right here and have you try it. Okay, let's talk about this one. First of all, we have a triangle sum theorem in here, which we haven't learned yet, but we're going to be able to use in this proof. This is not a common occurrence, but for this proof, the diagram is just the given. Then we say angle 2 and angle 3 form a linear pair. Just by looking at the diagram, we see that 2 and 3 form a linear pair. What's our reason? Definition of linear pair. Right? See what it says up here? You use the definition when you're just looking at the diagram and describing what it is. Okay, then, since 2 and 3 form a linear pair, we can use the linear pair postulate, which states they're supplementary. So you actually have to have the word supplementary. Angle 2 and angle 3 are supplementary. Then you can say measure of angle 2 plus measure of angle 3 equals 180. By what reason? Good definition of supplementary. Now, this was inserted in here. You're not expected to be able to insert that into your own proof, but it says measure of angle 3 plus measure of angle 4 plus measure of angle 5, 3 plus 4 plus 5, are angles of a triangle. They add up to 180 because of the triangle sum theorem. But what does that do? That gives us two steps here that are both equal to the same amount. That is always going to be a signal to you to use the substitution property. When you have two things equal to the same amount, you're basically taking 2 plus 3 and keeping it the same, and then taking your 180, getting rid of that, and replacing it with 3 plus 4 plus 5. That's substitution. Whenever you see two steps that are equal to the same amount. Okay. Last one, subtraction property. What are we going to subtract from both sides, Thomas? Good. So you end up with exactly what you're trying to prove. Yep. Yep. We've had some already with more than one given. Like here, look at this one. But yeah, and sometimes the question was, can there be more than one given in a proof? Yes. Sometimes there's one given, sometimes there's 3, sometimes there's 5. You can list them all in the first step and put given, or sometimes they break them out. They use them at different times. They use them when they need them in the proof, and that's okay too. All right, last one, complementary angles. Angle B is congruent to angle C. Now, anytime you have givens that you could mark on a diagram, you should actually mark your diagram. right? If you are told things are congruent or something's a midpoint or whatever, you can mark the diagram. B is congruent to C. Angle A and B are complementary. Angle 2 and C are complementary. So we are going to start with all the givens. Angle B congruent to angle C. A and B complementary. I'm going to abbreviate here. And 2 and C are complementary. That's all given. Based on that first given, angle B is congruent to angle C. We can say angle B is equal to angle C. Reason? Emerson? Good. The next reason says definition of complementary. What do you think we're going to write here? Jamin? Measure of angle A plus measure of angle B equals 90. Measure of angle 2 plus measure of angle C equals 90. Very good. Definition of complementary. Remember what we said up here? When you have two statements that are both equal to the same amount, you can set those two things equal to each other, which is basically what we're doing here. A plus B is here, and 2 plus C is here. So if two things are equal to the same amount, you can set them equal to each other by what reason? Substitution. Okay, now look. A, we're going to use substitution again. A stays the same, B stays the same, 2 stays 2. C gets changed. What is C going to change to? What's C going to change to? Molly? B. Measure of angle B. Because we've established here that B and C are the same. Now, what happens from this step to this step? What did they do to both sides to get measure of angle A by itself? Yumi? Good. Subtraction property of equality. They subtracted the measure of angle B from both sides. Boom, boom, gone. Now look at this statement. Angle 1 and angle 2 are vertical angles. Angle 1 and angle 2 are vertical angles. Reason? Exactly. We're just stating that they are vertical angles. Definition of vertical angles. The next one's the vertical angles theorem. So what are we going to say? Ion? Okay, so angle 1 is congruent to angle 2 by the vertical angles theorem. Now we can say their measures are equal. Definition of congruent. Now we can say measure of angle 1 equals the measure of angle A. Why? Substitution, because 2 and A are the same. And then measure of angle A equals measure of angle 1 by symmetric.